Hello, yeah, in this video, I want to walk you through the steps of performing a one-way ANOVA analysis using a synthetic data set. Okay. First, let's set a random seed for reproducibility. Next, let's create the data set. First, let's create a group levels, which is a factor with group 1, group 2, group 3. That's 3 levels. And next, let's create sample size 30 for each group. And then the data for each group, we generate this data from 3 normal distributions with different means, the same standard deviation. Okay. And next, we put together this data. So you can say we use the data frame command, put together values and group. The values are the data points, and then the group is the factor, the group variable. So we do that. Then we have a data frame called the data. Okay. The next thing is we can perform the one-way ANOVA analysis by simply calling the R function AOV. And the syntax is values regress on group, then data equal to data. If you really need to know more about the detailed information about AOV, you can use this question mark AOV. It should give you all the detailed information about this function. For example, it says AOV stats. That tells you AOV is inside the package called the stats, which is in base R. So we don't need to install that package and then load it into the RStudio session here. Then it tells you the purpose of this function and the usage and all the details of the arguments, and including some are sample syntaxes. So you can spend some time reading the documentation to learn more about the AOV function. Okay. And then once we create this object called ANOVA model, we can print it out by using summary ANOVA model. You can see down there, this is a typical ANOVA table, right? You got the degree of freedom, sum squares, mean squares, F value, and the P value. And then you have the between group sum of squares and the residual sum of squares. And you can see the p-value is very small here. That's indicating there's significant differences across these 3 groups. So we need to reject the null hypothesis of all the group means are equal. So when you are performing an ANOVA and you rejected the null hypothesis, then you know that not all group means are equal. Then the subsequent question is exactly which 2 groups have different means. And for that, we need to perform post hoc analysis. And when we do pairwise comparison between 2 groups, then the number of tests increase very rapidly. That will create the inflation of type 1 error issue. So that's why we must do multiple adjustment using different methods. A very popular method is called the Tukey's honest significant difference test, the Tukey HSD. Okay. So there's the popular one, another popular test called the Baffarani test, Baffarani adjustment. But Baffarani adjustment is very restrictive. Okay, you may end up more frequently you're going to end up seeing no significant differences between groups. Here we don't have time to really go through the detailed mechanisms of Tukey HSD method, so I just want to show you how to use it. And Tukey's HSD function is in the base R package, so you don't have to install any additional packages. You can just use it. So post hoc assign as the output of Tukey HSD, and you put in that ANOVA model object, ANOVA model. And of course, if you want to learn more about Tukey's HSD, you can use this ask for help. You can read more details about this procedure. And also you can print out the result of this post-hoc test. It shows you the group 2 minus group 1, group 3 minus group 1, and group 3 minus group 2. And you can see group 3 minus group 1 is significantly different even after the adjustment. And group 3 minus group 2 is also significant difference. And the differences are all positive, so that means the group 1, group 3 had higher mean than group 1. Group 3 also had higher mean than group 2. But we cannot detect a statistically significant difference between group 2 and group 1. Okay, and then you can, if you want something visual, you can use the plot function. You'll create these plots. You can see the first one is group 2 minus group 1, so it overlaps 0. Zero falls within that confidence interval, so they're not significantly different. Okay, so this gives you some visuals about these results. And all these functions, AOV, 2-key, HSD, they are in the base R, so we don't have to install any additional packages. So it's a fairly straightforward to perform a one-way ANOVA analysis. Thank you.